The extensive campaign that was undertaken with the VLA and the GMRT covered um, both high frequency radio emission from the supernova. And to understand the characteristic of this supernova, we have to step in a little bit into a territory of energetic charged particles radiate electromagnetic radiation in a region of strong magnetic field. Strong magnetic fields are generated by supernovae, or any seed magnetic field which is present in the progenitor's atmosphere is strong when the shock actually plows through this region which contains a seed magnetic field, and amplifying this seed magnetic field amplification. So you also have energetic charged particles, especially energetic electrons. There are also energetic protons, but as far as radio emission is concerned, it's the electrons which are the most important ones, because they're so light. These electrons are themselves accelerated by the shock waves, which are launched by either the supernova or the GRB, and they radiate in the magnetic field through synchrotron radiation. Synchrotron radiation is something that people who were devising effect of because that was a serious source of loss of energy when they tried to accelerate particles, and electrons really suffered the greatest amount of synchrotron radiation losses, whereas the protons did relatively less. And similar things also happen in supernova. The supernova accelerates electrons to a range of energies and range of speeds, and the highly energetic electrons among them radiate in the magnetic fields at high frequencies, and whereas the relatively lower energy in lower frequency bands of radio. Now, it so happens that there are regions of the supernova where the density is so large that whatever emission it might be creating because of synchrotron radiation at lower frequencies, they are absorbed by the electron that are present in the gas, and that leads to the so-called synchrotron characteristic rise to a peak, and then a fall from the peak, and they occur at relatively low frequencies and relatively high frequencies. It's a high frequency regime which are believed to be taking place in an optically thin regime, meaning the high frequency radiation are not effectively absorbed by the electrons which are present without hindrance. And it is this characteristic spectrum which is often seen in supernovae and GRBs, and they can also be utilized to interpret conditions in the plasma. And this is precisely what we saw in 2009 BP, as the next slide shows. So here we have a composite spectrum which is observed by combining GMRT and VLA. On the extreme right, you have the spectrum which were seen by these telescopes on April 8th or on or around April 8th. And you can see that the peak of that radiation spectrum is close to of the order of 10 gigahertz. But as time went on, and you went from April to May to June to August, the peak of the distribution, peak of the spectrum shifted slowly into lower and lower frequencies. The emission strength also decreased a little bit, but it was the emission peaks shift to the lower frequencies that is quite pronounced, and it can be related to how the radius of the zone which is emitting the plasma is changing with time. And below this figure I have written out the radius of the region which is emitting this synchrotron self-absorbed radiation as a function of the peak frequency and the peak luminosity, the peak radioluminosity. On the right, there is also an expression for the magnetic field, which you can also derive from where the peak of the spectrum is on a given day and what the luminosity peak is on that particular given day. And this is actually quite useful in measuring out the speed of the emitting plasma, which is moving out as the supernova ages. And it is this radius's variation with time which show a special relativistic motion, namely motion of the plasma close to the speed of light. It also allowed us to interpret the amount of energy contained in the radio-emitting plasma purely from the radio-emitting plasma's characteristics. Next slide. The extensive campaign that was undertaken with the VLA and the GMRT covered